Welcome back, Patriots. Our second set of notes here. Again, this was going to look kind of funky whenever you print it out. Again, this is meant to be a double-sided booklet, but there's only one page, so there's not all that funky folding to do this time. So if you don't even fold it, that's fine. It'll all work out in the end. Okay, we're going to be covering division of polynomials. Now, when I say division of polynomials, I'm talking about stuff like this, which up till now you haven't had to do before. But before we can do that, we've got to remember how long division works. So all these problems, I do not want you running to the calculator and just typing it in. We're actually going to be practicing our long division skills because those long division skills are absolutely necessary in order to finish the problems on the second pages. So take a trip back to elementary school and do long division by hand. I know you haven't seen this stuff in a long time. Okay, so we're going to say, how many times does 3 go into 8? Well, you know what I'm going to do here? I need to, oops. I need more room, so I'm just going to wipe that out. Okay. How many times does 3 go into 8? Well, 3 will go into 8 2 times. So then we multiply 3 times 2 to give me 6. And now I subtract it out. 3 times 6. I'm sorry. 8 minus 6 gives me 2. And then these all just drop straight down. So I've got 2 and 5. Well, now I look at my next place. 3 can't go into 2, but it can go into 22. So 3 goes into 22 7 times, and 3 times 7 is 21. Subtract that out. 2 minus 1 is 1, and then my 5 drops down. And now we say, how many times can 3 go into 15? Well, it will go in 5 times. 3 times 5 is 15. Subtract it out, and I got 0. Now at this point, if that was a number, I'd have a remainder, but I don't, so my answer is just 275. Okay, let's do number 2. Now when we have a division problem written out this way, I need to rewrite it. 358 divided by 5. Okay, we're going to say how many times does 5 go into 3, and it doesn't. So I could put a 0 there, but I don't have to. I just need to scoot over to be above the 5, which is my tens place. So now I say, how many times will 5 go into 35? Well, that will go in 7 times. So we do 7 times 5 is 35. Subtract that out, and then we're going to drop down the 8. 35 minus 5 was 0, so we left with just the 8 below. Now we say, how many times can 5 go into 8? Well, that will only go 1 time. Now we multiply 1 times 5 is 5. Subtract those, and I get 3. Okay, now that I've gotten to past the ones place, I could keep on going for decimals if I really wanted to, but the very first the way you introduced this, the very beginning, was to do this, to say remainder 3. So a 71 remainder 3. Now we're going to be doing something similar with our polynomials. We're going to be writing our answers like this: 71 plus 3/5. Now I realize we should just write that as a mixed number, 71 and 3/5, but the important thing is the divisor is going to be the denominator. Okay, so that's what's going to go over there. Also, our remainder is what ended up on top. Okay, so 633 divided by 2. We need to rewrite that as a long division problem. So how many times does 2 go into 6? It goes in 3 times. 3 times 2 is 6. Subtract those, and I get 0. Let's go ahead and drop our 33. Now, how many times will 2 go into 3? Well, 2 will go into 3 1 time. So 1 times 2 is 2. Subtract that and I get 1. The 3 drops. Now 2 will go into 13 6 times. Subtract that out and we got 12. I'm sorry, multiply 6 times 2 gives me 12. And subtract that I get 1. I'm now at my decimal. And so I'm going to write my answer as 316 and 1/2. 316 remainder 1. All right. Now, this one's a little bit more complex. 4 can't go into 1, so we move on. 4 can go into 10 twice. 4 times 2 is 8, so subtract that out, and I get 27. Drop the 5 and the 6 as well. Now, how many times does 4 go into 27? Well, 4 will go into 27, I believe it's 6 times. 4 times 6 is 24. Subtract those and I get 3. The 5 and the 6 drop. Now, how many times will 4 go into 35? Well, I believe that is 8 times. I'm getting lined up badly here. It was a 2, and then it was a 6. Okay. Now, it will go in 8 times. So 4 times 8 is 32. 35 minus 2 is 3. And now my 6 drops. And then 4 will go into 36 9 times. So my answer is just 2,689. Whew. Okay, I hope that wasn't too torturous for you. Hopefully, honestly, that skill, looking back on it years later, was a little bit easier than the first few times that you did it. Now, when we do polynomial division, we're going to actually divide in the exact same style. But there's 2 things that we've got to check first. We need it to be in descending order. Okay, so powers, largest power to smallest power. That is number 1 there. The second piece is we have to make sure that all the powers are accounted for from beginning to end. Now, if there's any that are missing, we are going to replace it with a 0. Okay, that's kind of like this one right here, 10,756. Now, again, remember how we first started doing place value way back in elementary school. We started doing, this was 10,000 plus 700 plus 50 plus 6. And there wasn't a thousands place in there. It's 0 times 1,000. Now, again, you wouldn't write that in elementary school, but you had to recognize that the thousands place was missing. And when you combined it together, if you just wrote 1756, you got it wrong. Okay, you've got to put that 0 in there for the thousands place. Okay, so we have to have the exact same thing when we're talking about our polynomials. You'll see that when we get to number 2, I'm just going to go ahead and circle that one in green because we're missing the x squared term. Okay, so we'll come back to that when we get to it. All right, also realize I originally intended on doing this a little bit different. These directions don't exactly apply. We're just going to do all of them here. Okay. So what we're going to do is we're going to rewrite this as a long division problem. I'm going to check to make sure that we're in descending order. Squared, first power, none. We're good. Again, first power and then constant. We're good. And then I want to make sure that everything is accounted for, which it is. And so we can just go ahead and move on. Now let's write this as x squared plus 4x minus 8 divided by x minus 2. Now you are going to be keying off of the first term here, okay? So we're going to multiply or figure out how many times will x squared or x go into x squared, or what would I need to multiply x by to get x squared? Well, in this case, it is just an x. Now we're going to multiply the x times x minus 2. But again, we have to distribute that. X times x is x squared. X times negative 2 is negative 2x. And yes, it is not a coincidence, or no, it's not a coincidence that I lined up these two and I lined up these two. See, what's been going on this entire time and why it was a big deal that I said I was out of line on number 4 is because I'm always having to make sure I'm lining up the hundreds, the thousands, the tens place, not just here on top, but also on as I went down on all of these, okay, as I went down through the problem. So we line those up properly. Now we're going to perform a subtraction step. But remember, when you subtract something, you have to distribute the negative sign. And so we have to change all of our signs. X squared and x squared, those cancel out. They should. If they do not, you've done something wrong. And then 4x plus 2x is 6x. And then the remaining stuff will drop down. Okay, now we're going to say, again, we're keying off of our first piece here. How many times will x go into 6x? Well, it'll go in 6 times, and I've got to have a plus. If it was a negative, you'd put a negative there. Okay, or a subtraction. Okay, so now we're going to multiply through. 6 times x is 6x, and then 6 times negative 2 is negative 12. Now, just like before, we're going to subtract, which means we're going to change all of our signs across here. Again, these should cancel out. If they didn't, you did something wrong. And then negative 8 plus 12 is plus 4. Now, once I get to the point that the piece that I've been keying off of, the x, will not go into the one on the bottom row, then I'm done, and this thing is considered my remainder. But again, I don't just write x plus 6 remainder 4. The way I'm going to write my answer is x plus 6 plus the remainder over the divisor. It's x plus 6 plus 4 over x plus 2. And that's my answer. Okay. Number 2. Again, I pointed this out earlier. I'm missing the x squared term here. So when I go to convert this to a long division problem, I have to write x cubed, and I need the 0x squared in there in order for this to work as a placeholder, just like I had the 0 in the thousands place on the problem before. Now I do plus 4x plus 6, and now I do x squared plus 1 on the outside. Again, we're keying off of the first terms. So how many, or what do I need to multiply by x squared to get x cubed? That's just going to be an x. And now we're going to multiply through. X times x squared is x cubed. X times 1 is 1x. Now we're going to subtract everything out. Again, this first term will cancel out. And then 0x squared. Oh, you know what? I need to make sure I'm doing things properly here, because notice I didn't line things up properly. I got an x squared with an x directly below it. This should have been lined up in the right spot. So this should have been plus x. And actually, I messed something up as well here. I forgot that we didn't have the 0 or the x term. Now, remember how I said we got to add in all that stuff because it makes things line up wrong if we don't? What I just did is why we have to do that. So I'm going to go ahead and scoot all this over, and I'm going to write x squared plus 0x here. And I'm still keying off of this. And now when I do this distribution out, realize what's going to happen there is x times x squared is x cubed. X times x, we got plus 1 here. X times x is plus 0x squared. And then x times 1 is x. Okay, so then when I bring this down, 0x plus 0x is still a 0x squared. Again, that should have been subtracted there. And that came from the subtraction that I did across. 4x minus x is 3x, and then this one drops down for plus 6. Okay, now, again, this one technically doesn't have to be written here. We're at the point I was at earlier where x squared cannot go into 3x. So I'm at the point where I'm able to write my remainder. This is my remainder. So the answer is just x plus 3x plus 6 over x squared plus 1. Remember, your denominator there is still the denominator there. The denominator in the problem is still the denominator in the answer. Okay, I apologize. That was not my best example I've ever done. Let's do better on this problem here. Okay, so we're going to check to see if any pieces are missing. I've got x squared, x to the first constant, good. X to the first constant, we're good there. So we're going to write this as x squared plus 3x minus 40 divided by x minus 5. And again, we're keying off of these two. So x will go into x squared, x times. We're going to distribute that through. X times x is x squared. X times negative 5 is negative 5x. We're going to subtract this out, and that will leave me with those canceled. 3x plus 5x is 2x minus 40. Now, again, we're keying off of the 5 and the 2x. Sorry, the x and the 2x. X will go into 2x 2 times, so we'll put plus 2. Now we're going to distribute. The 2 times x is 2x. 2 times negative 5 is negative 10. We're going to subtract this line, and that's going to leave me with those cancel out. Negative 40 plus 10 is negative 30. Now, x cannot go into negative 30, so my answer will be x plus 2 plus, sorry, it's a negative 30, so it's minus 30 over x minus 5. All right, number 8. I notice here that I've got x to the fourth. I'm missing an x cubed term. X squared, x to the first constant. I also noticed that I'm missing an x to the first term. So I need to make sure that I account for those whenever I write my problem, and we'll do it actually right this time. Okay, 8x squared plus 0x cubed minus 4x squared plus x plus 4, all divided by 2x squared plus 0x plus 1. Okay, 8x, and that should have been a fourth power, and 2x squared. Okay, that will go in 4x squared times. Now, 4x squared times 2x squared is 8x to the fourth plus 0x cubed, because x squared times x is x cubed, and then plus 4x squared. Now we're going to subtract this out. Again, those canceled out. Again, these went away there. Negative 4x minus 4x is negative 8x squared plus x plus 4 just dropped down. And now, again, I'm keying off of this one. Let's see, the 2 and the negative 8 means I need a minus 4 and x squared, I don't need anything there, so it's just a minus 4. Negative 4 times negative 2x squared is negative 8x squared. Negative 4 times 0x is plus 0x. Negative 4 times 1 is negative 4. Now I'm going to, again, subtract, so all my signs get changed. Those cancel. X plus 0x is x. 4 plus 4 is 8. And now I'm at the point where I got an x squared on the left and x on the right. I can't do anything with that, so I can write my answer. It will be 4x squared minus 4 plus x plus 8 over 2x squared plus 1. All right, I know that can be a difficult lesson. Like I said, reach out to me. Send me an email. Jump into my Google Meet every morning, 8 a.m. on Google Meet. That's the code is EVHS Mr. Love. And otherwise, good luck on your assignment.